So let's go ahead and take another look at chemical equations, and we'll see that they actually give us some really interesting information that we haven't used so far. So pretend we want to make some ammonia. Why might you want to make some ammonia? Well, you might want to go ahead and clean your mirrors in your bathroom. Ammonia is wonderful at cleaning mirrors. Or maybe you want to oxidize it up and make fertilizer to feed half the world. That's also a very good reason to make ammonia. And this process has been around for about 100 years. It's called the Haber process. We take nitrogen from the air, which we combine with hydrogen from various sources, and it turns into ammonia. It is a very hard reaction, actually. It takes very high pressures and temperatures and all sorts of exotic materials to catalyze this reaction. But what does it actually tell us? Well, one way to look at it is that it tells us that for every one nitrogen, it takes 3 hydrogens to react. Or for every 1 nitrogen, you end up making 2 ammonias. Or for every 3 hydrogens you have, you end up making 2 ammonias. So that's a couple of different ways you can look at it. We can also just multiply all of this stuff by a very cool number, Avogadro's number. So we can multiply by 6.022 times 10 to the 23, which really is just multiplying by a mole. And this now tells us something very, very interesting. It says that 1 mole of nitrogen, when we react it, needs 3 moles of hydrogen. And also when we react 1 mole of nitrogen, 2 moles of ammonia, so NH3, are produced, and 3 moles of hydrogen, when they react in this reaction, can make 2 moles of ammonia. And you can see those numbers here, the 3 and the 2, are really just coming from these numbers here, the coefficients, the 3 and the 2. So I always like to think of it, you basically just point your finger and, here's a finger. And the finger is the coefficient, and in the conversions below, that 1 nitrogen shows up as 1 mole of nitrogen here and here. And that 3 hydrogens here shows up as 3 moles of hydrogen here. And there it is, the other one. And that 2 moles of ammonia shows up as that 2 moles of ammonia here and here. So you really just need to point and, okay, so let's see, those are the 2 nitrogens. And those are the 3 hydrogens, so very cool. And if I want to know how hydrogen is related to ammonia, I point and I say 3 hydrogens. 3 moles of hydrogen react and make 2 moles of ammonia. So we can form these conversion factors super easy. So what do we do with them once we form them? Good question. So here's the sort of problem we can do from this information. So how many moles of ammonia, NH3, can we make from 2.4 moles of hydrogen? So this is a conversion factor problem. So we just have to take our hands. There's our one hand. So what do we want? How many moles of ammonia? So that's that right there. And hydrogen, that's right there. So, okay, so I got my 2 pointy fingers here. So I got 2 moles of ammonia are made from 3 moles of hydrogen. So we can write that as a conversion factor. So we can say 3 moles of hydrogen, right, equals 2 moles of ammonia. We basically just took our fingers and we just pointed one there and the other there. And what do we want to do with this information? Well, we've got 2.4 moles of hydrogen and we want to convert to moles of ammonia. So we just need to convert by multiplying by a conversion factor. So what are we going to need? We're going to need the 3 moles of hydrogen to go on the bottom because they need to cancel with the hydrogen on the other side. And the 2 moles of ammonia need to go on the top. So let's go ahead and put the hydrogen in first. We can convince ourselves that it needs to go first because moles of hydrogen need to cancel, because we're not asking how many moles of hydrogen can we make. We're saying how many moles of ammonia. So we got to end up with moles of ammonia. So moles of ammonia go on the tippy top. And when we do that and crunch the math, we'll see we get moles of ammonia and significant figures. That has 2. And these are all ratios. So these are exact. They're counted, if you like. We balance the equation by counting atoms on each side. So infinite precision there. And if we multiply 2.4 moles by 2 over 3, I think we get a cool 1.6 moles of ammonia. So we have done a little chemical engineering problem. We've helped to feed half the world when we do this kind of calculation. So 2.4 moles of hydrogen will beget, if you like, 1.6 moles of ammonia. How cool was that one, huh?